Hello everyone, in this tutorial I will demonstrate how to write a hello world program in Golang. First we have to create our source code file. Go. Then as the very first line of our source code file we have the package declaration, package main. Then we have the import statement, import fmt. This fmt package have couple of functions that can work with inputs and outputs. Then we have to declare our function func main. Inside the function main we have to call println function from package fmt. So fmt dot println with capital P, then hello world. Okay, now we have our hello world program. Let's save this file and run this. To run this source code, use go run file name hello.go. Here we have the output. Go file structure. Here we have our hello world program. At the very first line we have package declaration. Package declaration shows us which package does this file belongs to. Here in our hello world program, our source code file belongs to package main. Then we have import statement. Import statement shows us what are the functionalities we are going to use inside our source code file which belongs to outside packages. Here we have use println from package fmt, so we have import fmt package here. After that we have our function declaration. In this program we have used a special function called function main. I will explain about the function main in detail in upcoming videos. This is the basic structure of any Go source code file. At the very first we have the package declaration. Following that we have our import statements. Then we have our function declaration. Go packages. Every Go program is made up of packages. Programs start running in package main if there is no init function declared elsewhere. I will discuss about both of these functions in coming videos. There are two types of packages in Golang: executable packages, reusable packages. Executable packages start with package main, generates a file that we can run, for example .exe file. Then we have reusable packages. Codes used as helpers, a good place to keep reusable logics. Not an executable file, we can't run this file. We can import these reusable packages to get access to codes that are written inside another package. By convention, the package name is same as the last element of import path. For example, if we import package fmt, the package name is fmt. When we need to call a function from that fmt package, we call it by fmt dot the function name. Go imports. The import statement is used to give our package access to some code written inside another package. If we need to import other packages to our source code file, we can do it in two ways. Basically, if we need multiple imports to our source code file, we can use import statement for each and every package we need as this import fmt, import math/rand. Likewise, other than that, if we need to make our code look nicer, we can use this factored import statement. It will use one import keyword, and within brackets we can line up our packages one after another. Exported names. In Golang, a name is exported if it's begin with a capital letter. Exported names are accessible from outside its own package. For example, if we are going to import fmt package, commonly used function of that fmt package is println, as shown here. Println function's first letter is capitalized. Because of that, that function can be accessed from outside its own package. If it was a simple letter, we can't access that function. When importing a package, we can refer only its exported names. Any unexported names are not accessible from outside the package. Hello everyone, in this lesson we are going to discuss about function main in Golang. The function main is a special type of function, and it's the entry point of any executable Go program. Function main does not take any argument and does not return anything. Go automatically call the main function, so we don't need to call this main function explicitly. Every executable Go program must contain a single main package and a main function. In this example, this is the hello world program we wrote a couple of lessons back. It's in a main package and it has main function. Once we run this program, this main function call automatically and prints hello world in our console. Hello everyone, in this lesson we are going to discuss about function init in Golang. The init function is special type of function and it's called when the package is initialized. The init function is executed before the main function call. This init function is present in every package. If we take main function, it's only present in package main, but this init function is present every package. Same as the main function, this init function takes no argument and does not return anything. Go automatically call init function at package initialization. It is possible to create multiple init functions in same program, and those init functions executed in the order they are created. It is possible to create init functions anywhere in the program, and they are called in lexical file name order, basically the alphabetical order. The main purpose of init function is to initialize global variable that cannot be initialized in global context. I will explain about this global variables and global context in upcoming videos. Yeah, let's take a look at a sample code. In this code, we can see 3 init functions and 1 main function. When we run this code, we get output as hello init 1, following hello init 2, then hello init 3, finally hello main. As we can see, the hello init 3 is after the main function, but as the rule, init function executed before the main function, so all three init functions executed before the main function is executed.
Hello everyone. In this lesson, we are going to discuss about Golang functions. Go functions can take 0 or more arguments as its input. Also, Golang function can return any number of results as its output. Here you can see a sample Golang function structure. Golang function start with func keyword. Following that, we have our function name. Then we open pair of brackets. Within that brackets, we can mention our argument list with their corresponding data type. If there are any arguments, we can have a function with 0 arguments as well. Then after we keep a space and we open another pair of brackets to place our return type with its corresponding data type, if there is any return value generated by our function. Then after we open a pair of curly brackets. Within that pair of curly brackets, we place our function body. If our argument list have arguments in same data type, we can only mention that data type for the last argument as shown here. Hello everyone. In this lesson, we are going to discuss about name return values in Golang. If you have a function that only has a few lines of function body, you can use this name return values. A return statement without any argument returns a name return value. This is known as a naked return. In this example, we don't have any arguments in the return statement. So it will return the value of W3. This type of return statement is known as a naked return. Variables. The var statement can declare one or more variables, and the data type of that variables comes at the last. As shown here, we start with var keyword, following that xyz. Those are the variable names, and at last we have the data type. Var statement can be at the package or function level. That means we can have var statement both inside and the outside of a function. We can declare and initialize variable at the same time. As shown here, we have initialize x, y, and z here. Then we initialize it with 1, 2, and 3. When we do the declaration and initialization at the same time, we can omit the data type of those variables. We can declare and initialize variables of multiple types at the same time, as shown here. Short variable declaration. We can use this short variable declaration only inside a function. Otherwise, this will generate an error. As shown here, we can declare and initialize variables without using var keyword using this short variable declaration. Also, we can declare and initialize variables of different data type using this short variable declaration. Basic data types. In Golang, we have a list of 8 basic data types. First, we have bool for boolean. Then we have string for character string. Then we have int for integer numbers. Then we have uint for unsigned integer numbers. Then we have byte. Byte is actually a alias for 8 bits unsigned int. Then we have rune to represent Unicode points. Rune also a alias for 32 bits integer. Then we have float for numbers with floating points. Then we have complex for complex numbers. 0 or default values. If we declare a variable without initializing it will get the 0 value of that particular data type it belongs to. For example, if it is a boolean or bool, it will get false. If it is a string, it will get empty string. If it is a numeric type, int, uint, byte, rune, float, that kind of numeric value, it will get 0 as its default value. If it is a complex one, it will get 0 plus 0i. Here I have given a example code for this. I will share the Go Playground link in the description below. Type conversions in Golang. The expression t of v converts the value v to type t. For example, if we want to convert an integer value to float 64 value, the expression t of v will be like this: float 64 within brackets int value or variable. In this code example, we have an integer variable I which holds the value of 42. Then we are going to convert it to float 64 by using the expression t of v as float 64 within brackets I. Then we assign it to float variable f and we print it. In Golang, not all basic type can use this type conversion t of v. We can't use this t of v on bool, complex 64 and complex 128. In this code example, I have mentioned almost every possible conversions. I have placed this link on the description below. In the first code example, you may notice some new syntax if you are new to Go programming. First, we have this percentage mark d. It's a placeholder for an integer in decimal. It formats the integer I as 42. Then we have percentage mark dot 2f. It's a placeholder for floating point numbers formatted to two decimal values. Then we have backslash n, the new line character. It moves the cursor to next line after printing the formatted out. Type inference in Golang. Whenever we declare a variable without specifying its data type using one of these methods, first one is short variable declaration, second one is using var for initialization. The type of the variable will be determined using the value of its right hand side. In this code example, we can see we have variable v of type int. We get the type int because of it has 25 in its right hand side as its value. Then we have C of type string. Then we have G of type complex 128. This is how the type inference works in Golang. In this code example, you may notice some new syntax. This percentage mark T here, it retrieves the type of the variable at the runtime. Not anything fancy. Then we have \n, the new line character. It will move the cursor to next line once it prints the output. Constants in Golang. In Go, constants are immutable values that are set at compile time and do not change during execution of the program. Constants are declared like variables but with const keyword. Here I have mentioned three types of const declaration. First we have const declaration with type. Then we have const declaration without type. If we want to declare multiple constants at the same time, we can use this factored block. Constant can be a character, string, boolean or numeric value in Golang. But we can't use short variable declaration syntax, colon equal to declare a constant. Here are some examples for constant declaration and how to use them. First, we have constant without type. Then we have declare a constant with type string. Then in the second example, we can see a factored block to declare multiple constant at the same time. Enumerated constants using iota. Iota is a special keyword used to create sequential constant. As we can see in this example, we can create multiple constants using factored block. Then if we initialize the first constant using iota, the following constants will get sequential numbers. As we can see here, Sunday we initialize with iota, then Monday, Tuesday and Wednesday will get sequential number in order.